So my name is Björn Eriksen. I work as a technical evangelist at Microsoft in Stockholm, that is. My main focus is Windows Azure. So as a technical evangelist, I talk to developers, is the main audience, and primarily developers at software and services companies. So startups and also regular ISVs making a transition into the cloud and helping them build for or migrate to Windows Azure. So that is my main focus. But also as a technical evangelist, I do a lot of the talks also about Windows 8 and Windows Phone, which is two important platforms for us, and also Visual Studio, the tool for building a lot of the stuff that we do. So I got the question before we started about is Windows Azure taking off in Sweden right now? And I'm sort of the wrong person to give an objective answer to that. So I say yes, of course it is. But the truth is that we've seen really good growth in the startup community and also in the cloud service vendors community. We have one here tonight representing a cloud service vendor who made a transition from doing on-premises to the cloud. But the difference right now is that we also see a great growth in the enterprise space. So a lot of enterprise companies using the cloud for instance, for storage or for test and development. Maybe they don't want to move their entire mission critical system yet, but they start trying out and start finding solutions where they can benefit from running both on premises and also in the cloud. So today's talk is patterns for cloud computing, and just as we said before, it's sort of a general talk, a general session title, saying that it's patterns for cloud computing. So you might as well take these patterns and implement them somewhere else, of course. But I will also, of course, talk a lot about Windows Azure and what you can do with these patterns in Windows Azure and how Windows Azure is built for implementing these patterns. But I would like to first start off with just a quick overview of our cloud platform of Windows Azure. Just a brief introduction to the different services, the different options for hosting, and sort of the layout for the whole platform. So first of all, when we talk about Windows Azure, we talk about a flexible, open, and solid platform. So with flexible, meaning that you don't have to be the next Twitter or the next Facebook to build on a cloud platform. It's supposed to be a flexible platform that will fit your needs. So if you want to store pictures for your mobile app that you're building, or if you want to build a push notification service that pushes to your mobile app, or if you have a website for your family that you want to host, or if you're building something that really needs the scale, the global distribution and the scale, the platform should fit both of these scenarios, or everything in between, actually. And we build everything on open standards and open technologies. So there is no requirement to be running Windows to run in Windows Azure. You could run Linux, for instance, or you could build an app for iOS and use the backend service in Windows Azure. So you don't have to take the whole package to Windows or to Microsoft, but you could use and the different services. And we are building a lot of the stuff for the different platforms. So if, for instance, we have SDKs for PHP and for Ruby and for Java and for iOS and Android and so forth. So it's really important for us to be this open platform that can do basically anything you want. Anything that you have today that you want to move to the cloud or build for the cloud, we can host that. And the last part being solid is that if we're building a platform of this scale, of this size, the one thing that we can be certain of is that things break, and they break all the time. So hardware will break, our software will break, and stuff will change and move around and stuff like that. So we have to build a platform that is resilient to these changes. So for instance, if a server crashes, or if a whole rack burns up, or if a whole container of servers break down, it's not going to affect your application. And if it affects it, we're going to fix it as soon as possible. And all this of course, done fully automated, so we don't have to go in and do stuff to bring your application back online. So for instance, in some servers, when you are deploying it to, for instance, hosting a web application, you have to have it in 2 separate instances, so that if one goes down, we can route all the traffic to the other instance. And if we look at the data centers that we have, so we have a global footprint of data centers. We have 8 data centers today. So we have 4 in the States, 2 in Europe, and 2 in Southeast Asia, and also more data centers opening up. I think the next one is mainland China, which will be run by a partner, but it's the first data center provider in China that is not Chinese. And we also announced that we will open a data center in Australia. So these are the closest new ones opening, but more and more popping up all over the place. So those are the blue dots. So in Europe we have 2 data centers, one in Dublin and one in Amsterdam. And when you deploy your application, or if you create a storage account, or if you use a service, you can always choose which data center you want to use. So for instance, the Dublin data center is placed in a region called North Europe. So if you are deploying an application, you can say, I want to deploy this to North Europe. And our responsibility is that your data will not, or your application will not leave this data center, this region. It could be, for instance, that you are using a storage account, and this storage account could be geo-replicated. So that means that your data is also replicated to another data center, but in the same region. But you could turn this off, of course, if you want to stay in the exact data center location that you choose. There are certain times when data might move outside of your of the region that you have chosen, but in that case, it's when you basically ask for it. So, for instance, if you call the support, and at the moment the support technician is placed in India when at the time of your call, they are allowed to access your data, but that is of course because you asked them to that, or said that there's some problems with your data. And in that case, data might leave the jurisdiction where it's in, or the data center location. But otherwise, it will not leave the data center. So the green dots are content delivery network nodes. So we have, I think it's 35 CDN nodes spread around the world. We have a CDN node in Stockholm, for instance, which means that you can cache data closer to your end user. So that is a service that you can turn on your storage account, saying that these public assets or blobs are also supposed to be cached on the closest edge cache node. So inside the data centers we have servers, of course, but we don't order one new server and open the box and put it into the rack. We order a container of servers, and each container contains something like 15 to 3,000 servers, and we connect electricity, network, and water for cooling to these containers, and then it's up and running. So our software will see that there's a new container connected, and we can start deploying applications to these. You also see that some of these containers, or probably all of them, are sealed. So basically we never send a technician inside a container while it's operating. We just mark servers as not used or not usable if they are broken, and if enough servers break down in one container, we remove that container and replace it with a new one. So this is sort of the smallest unit of scale that we have inside of a data center. The data centers are of different generations. So I think this is generation 3 data centers with the containers. We have also generation 4 data centers, which is more built out of modules that you sort of connect into building the infrastructure. So you can break for questions at any time. It would be good if we have sort of a dialogue. So if you have any questions, just shout it out or raise your hand, and I will stop. So I would say the 3 main services. There is also one fourth, but if we start with the 3 main services for options for compute. So say that I have a website, for instance. Where should, or which service should I use to host this website? Well, if we start from the right, we could say spin up a virtual machine based on Windows Server 2012, for instance, and we start that machine and we give control to you. So basically what you need to do is remote or PowerShell into this server and say, okay, I need to have IIS installed, or I need it to act as a web server role, and configure it and open the ports that you need and so forth. So basically you take care of everything from the operating system and up, but we take care of running the server for you. So this is what the everybody call IaaS, so infrastructure as a service. If we go to the next step, we have something that we call Windows Azure Cloud Services. And with Cloud Services, you build applications based on different roles. So we have two main types of roles. It's a web role and a worker role. And with these, you can build sort of asynchronous or you build applications based on these roles. So maybe you have two web fronts hosted in a web role or in two web roles, and you have a bunch of worker roles that is background processing roles. And this is what what do you say? Det här var branschen kallar. This is what our business. Yeah, our business, or the IT world calls PaaS. So platform as a service. So these are the two main services that if you're talking to a cloud provider, this is what most of them offer. Most of the time they offer one of these two. So for instance, Amazon is very strong on infrastructure as a service. This is what they started to do when they realized that they had a lot of overcapacity they needed to rent out. They also have some sort of Java hosting platform as a service option that I'm not that knowledgeable about, but their main service is the infrastructure as a service and the storage service. If we're looking at the platform as a service, we have, for instance, Heroku as a competitor. We have also niche players like Nodejitsu, I think they're called, who does only platform as a service for Node.js sites. But one of the strengths I think with Windows Azure is that we have a very broad platform where we have both the platform as a service and the infrastructure as a service offering. And here you can have both Windows and Linux. And the third option is Windows Azure websites. So with Windows Azure websites, you can really fast spin up a placeholder for a site, and then you can deploy your site to this placeholder, either directly from Visual Studio. If it's an ASP.NET site, you can just do a web deploy to this site, or you can integrate it with GitHub or a local Git repository or a Team Foundation service, for instance. With websites, you can also run. You can also start from a template. For instance, you can create a WordPress site or a Joomla or Drupal or equivalent, and you really don't have any control of the underlying operating system. So we just basically hand you an endpoint. What we actually do is that we load your application or your web application in memory when it's needed, and if there's no requests to it, we will remove it from memory. So first time it will take some seconds before we can load it into memory again. With the platform as a service offering or the cloud services, you can adapt the underlying operating system. So you choose which version of Windows Server you are running on, but you can also change it with what we call startup scripts. So for instance, if you have a requirement of running an old COM component, or if you want to run Crystal reports or something like that, and you have a requirement that this should be installed on the server before it starts, you write a batch script or a PowerShell script that is executed before the server starts, or not before it starts, but when it started, but before it's taken online. And when that is done, then you start directing traffic into these services. What I don't have on this slide is also the mobile services. So that could be sort of a fourth, mobile services. And what this is that it's a turnkey solution for building backends, push notification, and authentication for mobile applications. So say that you're building a iPhone application. We want to enable the developers of this application to focus on building the app itself and not the infrastructure. So for instance, if you want to store a customer object, or if you want to store a high score list or something like that, you just create your object in your code, iPhone, Android, Windows Phone, or Windows 8, as an object, and you just say to the service, store this object. When the JSON object comes flying, we will open it up or see what we need to do to store this, and we will store it in a SQL Server database. So really easy service to be able to just build the backend and let you focus on building your application. We also have support for Android push notifications, iPhone push notifications, and the Windows and Windows Phone push notifications. So you just basically configure and say that these are my tokens from Apple push notification, for instance, and then from the API you say send notification, and you just send it via Apple's push notification service. And the same for authentication. We have Facebook, Twitter, Yahoo, and Microsoft accounts that we can integrate with for authenticating users. So these are the options you have for hosting your application. And except for that, we have a bunch of application building blocks that you can use to create your complete application, or just use separate. So for instance, you could use the storage mechanism if you're running on premises but you want to store your assets online or in the cloud or something like that. Or you could use the media service for transcoding movies from a source format to different formats that you want to push to or stream to different clients or stuff like that. And there's not a requirement to host your application in Windows Azure to be able to use these services, but they are rather complete separate entities that you could use together or could use completely separate. We also have, for instance, a big data implementation. So we have an implementation of Apache Hadoop, where instead of building our own big data implementation, we're taking the open source Apache Hadoop and built a implementation of that. So you could spin up a cluster of nodes and do MapReduce jobs, for instance, on our Hadoop implementation that's called HD Insight. So that is sort of also a strategy I would say Microsoft is taking, that rather than building everything for ourselves, we build on open technologies, and we would rather implement something that someone else has already built and using instead of building something completely on. We see the same thing in now that when we got Git support into, first of all, what's now called Visual Studio Online, what used to be called Team Foundation Service, and also with the release of Team Foundation Server 2013 with full Git support. So we saw that the market was sort of or this thing with distributed source control was becoming more and more popular, and we needed to adapt to this instead of our just offering our centralized source control system. So instead of building something completely on, we took the Git implementation and built a Git implementation completely integrated with Team Foundation Service and Team Foundation Server. So this was sort of the 10-minute overview of Windows Azure. This could have been a whole talk of its own. Do we have any questions on Windows Azure or the platform or these parts?
I haven't checked lately, but a year and a half ago, I thought I could deploy a private repository from GitHub, but I couldn't. It needs to be public. Do you support that as of now?
So the question was, some maybe a year ago, you couldn't deploy a private repository.
Only public ones.
Okay. I know that there's happened a lot around Git, especially for the last 12 months since we announced that we support Git in Team Foundation Service, but I don't know exactly.
I was talking about push deploy actually.
Okay.
So
Okay, no, I can't answer that. I don't know.
I guess I can just Bing it.
Or Google it on Bing. Any more questions? Yes?
Regarding databases, you have different options for using a SQL database. You have SQL Azure, you have some enterprise solutions,
Mm-hmm.
you have sometimes recommended installing it on virtual machines.
Yeah.
A lot of different options. What's the story behind that?
Yeah. So the question is databases. We have a lot of different options for SQL, for instance, or SQL Server-based options. It could be the Windows Azure SQL database. It could be the Windows Azure SQL database with dedicated resources. It could be a virtual machine with SQL Azure or SQL Server installed. And it's true. It's a lot of options. And apart from that, we also have support for Oracle, and we also have support for NoSQL solutions. So, but if we try to stick to the SQL Server solutions, first of all, I would say that it depends on if you can migrate your solution to the SQL Azure database, because it's not 100% compatible or feature-wise compatible with the on-premises or in-premises version of SQL Server. But if I had a database and I could move it to SQL Azure, I would definitely do it, to not have to maintain or operate the Windows install and the Windows operating system and the SQL Server. We have some limitations, for instance, on database size. So there's a limitation of 150 gigabytes on the maximum database size. If I couldn't go under that, then you would have to go to an installed version of SQL Server. And also what we will see later when we start talking about scalability, for instance, if you have a cloud service that you can scale out, and you have all of these going to one database, you might have issues. Because this database, if you're using Windows Azure SQL database, this database won't scale out and it won't be able to scale up. Well, you can scale up to the dedicated resources, but it won't do that automatically for you. So what you could do is move this to a VM, no, not W, a VM with SQL Server installed, because then you can scale up. You can use a bigger and bigger machine. It's still a limited to how much you can scale, because it's maxed out at 8 cores and 56 gigabytes of RAM. That's the biggest hardware we have today. But you could still do it. You could still scale up, and you know how much resources you will have available for this server.
Easier said than done, but you can also rethink your architecture.
Exactly,
And
exactly.
So microservice architecture.
Exactly, and do sharding and stuff like that. But we'll talk more about that pattern soon, or actually not that soon, but later. But it's a very good question, and definitely something that you need to think about when moving to the cloud. What kind of data store should I use?
So the steps are performance-wise, you can base it on SQL Azure, you can base it on a virtual machine, you need to scale up, and then you have these dedicated resources that's lying in between them.
Yeah, I'm not entirely sure how big you can go for the dedicated resources and how that exactly compares to the installed or installed alternative for a virtual machine. I can't exactly compare those, but I would say that the dedicated resources is the next step from using SQL Azure or Windows Azure SQL database. So that is the dedicated resource. And then if you need other enterprise features like always on, for instance, or if you want to do database mirroring or stuff like that, then you need to go to the install it yourself. Okay, so design patterns. I'm sure everyone is familiar with what a design pattern is, but this is one definition. So, general reusable solution to a commonly occurring problem. So something that happens all of the time when you do build cloud solution or build something that you see that, okay, here's something that we could reuse. We could use the learnings from doing this before and do it over again. It's general, so it shouldn't be specific to a platform or to a technique or something like that, but should be able to apply it on different scenarios. There are several books on design patterns written. All of these 3 are from the Martin Fowler Signature Collection, with patterns of enterprise application, enterprise integration patterns, and implementation patterns, going from sort of enterprise integration to real implementation. And also the elements of reusable object-oriented software from Gang of 4, which is sort of overview of the traditional patterns books out there. There are of course more pattern books, but none of these really talk about the cloud, and I haven't seen a book that's dedicated to cloud computing patterns. There are several sites that do this, and this talk that I'm giving today is based on something that the patterns and practices team from Microsoft have just released, which is a set of patterns and guidances for cloud computing. I will add reference to that later. So everything, I will definitely share my slides if anyone wants them, but also I will show the resource to all these documents where each of these patterns plus I think 20 more or something like that is described in detail with the implementation also. So there's a lot to read about the stuff that I'm talking about today. And also this is not a complete solution to every problem, but it's rather based on my learnings from working with Windows Azure for a couple of years, and also reoccurring things that I see all the time basically, and sort of breaking this down into different out of these lots of patterns that they have described. I picked out the patterns that I think is very interesting and that I see reoccurring all of the time. So the structure for the talk going forward is that I start with a context and a problem. So for a specific pattern, there's a context and a problem, so sort of describing what scenario that we want to solve. I'll talk about the solution, still in sort of general, but maybe going into more Windows Azure details in this case, and then implementation of this pattern. And I will also most of the time talk about some issues or considerations that you need to think about, or questions that you need to ask yourself when implementing this certain pattern. And these are patterns that I've chosen. So first out is multi-data center deployment, about deploying to several data centers and why we need to do that sometimes and how that could be done. I'm going to talk about Autoscale, compute resource consolidation. That is if you have several different components that act similarly or that could share compute resources basically to lower the cost. Direct client resource access control is that if you want to give out the possibility to access data directly from the client, not having to go through your service, the service that you're building. Asynchronous messaging being a huge topic, but really, really important. And the final one that we sort of touched here about sharding. So I think I haven't given this talk before, but I think it's a pretty content-heavy talk. So there will be a lot of talking, and I think I have demos for all of the patterns. So hopefully we'll sort of keep you awake by context switching between Visual Studio, the Windows Azure portal, and back to slides again. So stop me if we need to take a break. I think we had, did he say 7 or 7:15 when the other ones? 7:15. Okay, so 45 minutes. It's going to be intense. We skip the breaks. So multi-data center deployment. So typically when you start building a solution, you start with one deployment, one point of deployment. That could be a local data center, of course, or a local server that you're running yourself, or it could be a hoster, or it could be in the cloud from day one. But still, it's typically one data center being all of these three. And even though if you're running this in the cloud, you could still lose availability due to failure. So for instance, as we talked before, if you have a single deployment, you say that you choose North Europe, so your application is deployed in the Dublin data center, and the Dublin data center goes down. Well, then your application is gone. It doesn't help that you're in the cloud, because if the data center is gone, your application is also gone. So we have an SLA on 99.95% uptime on if you deploy to 2 instances, but there is still a 0.05% of the time where we don't guarantee that your service is up and running. So we say that we have an SLA, but an SLA is not, well, it is a promise that we're going to try to keep as hard as possible, because if we don't keep our SLA, we will give money back to you. Not every SLA that you see out there, every cloud SLA is financially backed, but we will pay you back money if our service goes down, or if we don't meet our monthly SLA. But an SLA is still a promise that we try to keep. We can't, of course, promise 99.95%. But that is our best intention, definitely. We have had several incidents over the years when Windows Azure or parts of Windows Azure has been not reachable. And in that case, you need to have a backup strategy. What do I do in the case where all of Windows Azure breaks down, or if one data center breaks down, or if my application where I'm running right now breaks down, or stuff like that? So these are 2 reasons, but also another reason for multi-data center deployment is that the world is getting smaller and smaller when it comes to going global. So if you start a startup today and you build a really cool game, the next day, the day after you're published in the app stores, you could basically go global, and you need to handle that. So it's a lot easier to do that today than before. And one way of solving this is, of course, to do the multi-data center deployment. So the solution, well, deploy to multiple data centers. And this is, of course, to reduce the risk of losing availability. This could be multiple data centers in one region. So for instance, you say that my data or my application have to stay within the European region, for instance. Then you could deploy to North Europe and to West Europe. So you have 2 different deployments in the same region. But it could also be globally distributed, that you have your application both to the States and to Europe and to Asia. So you are covering the whole globe. It could also be different cloud providers. So for instance, I could deploy my application to Amazon, and I have a backup running in Windows Azure. So in the case that Amazon fails, I will redirect or reroute my traffic to Amazon. Or for instance, I could have a load balancer between these 2 and route traffic between the different data centers. It could also, of course, be running in the cloud and running on premises and switching between these. So reasons for deploying to multiple data centers. Well, disaster recovery is one thing. So say, for instance, that I have my application running and my connectivity to the data center goes down. What do I do next? How do I recover from this disaster? Well, for one thing that you need to do is that you need to be absolutely clear on how do I set up a new deployment of my application and have that automated as far as possible. So basically what you want to do is you want to do one-click deploy. You just want to push a button and say deploy this to another data center or to an on-premises or to another cloud provider. So disaster recovery is one thing. Another option is to have a hot swap available. So I would say between these 2 options is just a matter of cost. Could I have my major deployment up and running over here, scaled out to maybe several instances in this data center, and then have another one standing by, but just maybe just one instance? And if this fails, I will reroute all my traffic to this one instead and scale out. So as soon as I know, I could start using my hot swap and then scale that out. But it could also be that I have a load balance solution between two data centers. So for instance, if my users are in Sweden, I could deploy my application to both Amsterdam and to Dublin, which is sort of the same latency from Sweden, and I could route my users to these different data centers all the time. And also, as we said, global reach with minimum latency. So if I have a deployment that's hosted both in the US and in Europe and in Asia, I could have a user from Sweden, for instance, running to Amsterdam, and I have a user in Mexico going to San Antonio, and I have a user in Japan going to Singapore or something like that. So based on where you are in the globe, you could reach the closest data center to minimize the latency that you get. But this is not a complete solution. So just because you deploy your application to different data centers, so I say that I have my app us.something.net, and I have my app EU.net something. There is nothing automatically mapping these two discrete services to each other, saying that DNS servers around the world should route traffic to the closest one. So there are different routing alternatives. You could use a DNS round robin, which maps a new domain name. So you have www.myapp.com, and this is the one routing the different traffic to the different users. Or you could have a rerouting on application failure. So for instance, if as we said before, you're routing all the traffic to this one, and if this one fails, you reroute to another data center. And building this is not easy, so it's very hard to get it right, and it's also very dependent on DNS caching, for instance. So DNS names are traditionally cached on the client, maybe for 30 minutes or 1 hour or even longer, and so it could be hard to get this right. And there are several service providers that provide these kinds of services. So for instance, you have Akamai, SoftLayer, Arbinet, and also our own Windows Azure Traffic Manager. So what these services does, or actually what Windows Azure Traffic Manager does, which is our implementation to solving this pattern, is that it combines failure detection with dynamic DNS routing. So if we have this solution that we said that we have two deployments of our application, and we have Windows Azure Traffic Manager taking care of routing the traffic between these two services, we also detect that if this one breaks, we will reroute all the traffic to the other service. And you could choose different policies. You could have a round robin, so just basically routing all the traffic to the next available data center in the list, or you could do a failover, which we talked about, or we could do a performance, which is routing to the closest one. So all of these policies are implemented in the Windows Azure Traffic Manager. Do we have any questions about multi-data center deployment? Cost. I do not remember the cost. So the question was about cost. One thing that you need to be aware of is that if you're deploying to two data centers, you have double the cost from day one, since you have one setup running in one data center and another setup running in the other data center. I don't think that we are charging for using the traffic manager, but I'm not entirely sure. We have to check that. But you have double the cost if you double the deployment. So if you're running 10 web fronts in in Southeast Asia and 10 web fronts in Europe, then it's 20 in total. So if we are switching to Visual Studio to wake you up, I have created a small application. So this consists of let's see if I can zoom in, not project. So I have this would probably be the same project. For in this case, I'm just to be able to show that I'm running in the States or in Europe. It's just a basic HTML page that displays the name. If this would have been the same, I could have checked this in the database or whatever, or checked which area I'm running in. But just to keep it simple, it's two complete separate applications. One is deployed to a data center in Europe, and the other one is deployed to a data center in the States. So to deploy this, I just right-click on the cloud service, and I say publish. And when I do the publish, I can, if we back up here, if you haven't seen this before, I select the cloud service. It's East US. I select the environment and the release configuration and the service configuration. So these are just different parts that you can play with when you are doing a deployment. And then I just hit publish, and 5 to 8 minutes later it's up and running in that data center. I could also set, let's see if we are opening properties for the this role. I could also set the instance count, that is how many instances do I want to run for this service, and also the virtual machine size. So in this case I'm using an extra small to be able to let it use as little resources as possible that I have in my demo account. Whoop. Minus and back to Visual Studio. So if we look at the management portal for Windows Azure, we see that I have two cloud services. So I have this one, multi-DC Europe and multi-DC US. And if I enter one of these and see on instances, I see that I have one instance running of each of these. So what I've been using now is the Windows Azure Traffic Manager. So for instance, I could go into the dashboard and find the URL for this. So it's called multi-DC Europe cloudapp.net. And it says that I'm in Europe. And if I change this to multi-DC US, it should say USA. And then the next service I'm using is the Windows Azure Traffic Manager. So if we scroll down here and Traffic Manager, I can create a new Traffic Manager, and I just give this and here I can choose which load balancing method I want to use. So we have the performance, which is routing to the nearest data center from me, round robin, which is just spinning it round the list, and failover, that is if one fails I will route to the other one. You can use performance, and this is just to show you how it's created. I've created one before because of the DNSs take some time to set up. This is now inactive, and here I can add an endpoint, and here I can choose which data or which cloud services should be a part of this Traffic Manager routing namespace. But if we look instead in the one that I already created, then I pointed out to the multi-DC US and the multi-DC Europe, and they are both online. So if I look at the dashboard, I should have a URL to the Traffic Manager here instead. So beriksen.trafficmanager.net with performance. Oh, where did my... It's totally disappeared. So I'm gonna sign in again. see if we can get back to where we were. Traffic manager. And the Eriksen. So now when I hit Eriksen.trafficmanager.net, it should say Europe because I'm closest to the European data center. But if I, for instance, go into remote desktop to this cloud service in the US, and I say instances, and I want to connect to this this cloud service. Connect. So now I'm connecting to the cloud service running in the US web USA _in_0. So now I'm connecting to a server standing in somewhere in the United States, and then I should be able to be routed instead to the service running in US. So now if I check from here, it says USA. What I've also done is that I've created a CNAME record for the domain name, so I don't have to use the Eriksen.trafficmanager.net, but I'd rather use the multidc.net, which is a domain name that I registered at GoDaddy, and just map that to the deployment that I have. Okay. So we go back to the slides. Application building blocks was not the one that I was going for. Multi-DC deployment. There you go. So some issues in consideration. Well, the main issue I would say is data synchronization. Say, for instance, that your user is using your application from Sweden all of the time, and you have a data store based in North Europe. So you have your application in North Europe, and you have a data store, and then you have your application in US, and you have a data store, and then you have one user that's accessing your application here basically all of the time, but on a travel going over here, access this site. How do you ensure that your data is in all of these locations? That is something that you need to think of. We have services for, if you're building on SQL, we have services for synchronizing between data stores, but if you're using something else, then this is definitely something that you need to take into account. It could be, for instance, that your service saying that, okay, I tried to find your data, but I didn't find it, so I will go into your main data center location where you last logged in or something like that. Or you could set up a synchronization between all of these data stores. So it all depends on how you see the typical usage scenario for your users. Data availability also, if my data is not available here, will I go look for it and synchronize it, or will maybe I just route this user over here instead, or something like that. So there are different options that you could use. You also have the regulatory restrictions. What if you have personal identifiable information that runs under the Swedish personuppgiftslag, and you have stored this in here, which is in the EU, which is okay by your compliance, and all of a sudden your user is logging into your site from somewhere else, and you start synchronizing your data over to the States. So these kind of questions you need to take into account, and also of course the customer experience. Maybe this is your solution, that you have your US users being routed, or the data being routed over to your single one data store, and you instead build a huge cache here. So basically it's just the writes going through and all the reads are cached, for instance. Could be all of these solutions, all depending on what kind of data you have and how you are accessing it. Okay, that was pattern number 1. Pattern number 2 being autoscale. So this is sort of the classic diagram of how if you want to sell the cloud to someone that doesn't know anything about the cloud, this is what you could draw. So you have some IT capacity, and you have the time, and you have a load forecast saying that, okay, I'm going to grow over time, and I know that sort of this is my expected forecast. Okay, to be able to do this, you need to allocate IT resources. And the same way as when you start a new company, you maybe start small, and then you need to expand more than you actually need. This is the exact same with IT. You buy 2 servers and you set up your site, but maybe you only have 2 users using it, so it's really underutilized. And as the forecast grows, you know that, okay, every quarter I need to buy 2 new servers and 2 new servers and 2 new servers. But if your actual load looks like this, your load forecast is still sort of in the same area, but it changes getting there. Well, you have too much power a lot of the time. You have not enough power other times. So for instance, here you got an article on some famous magazine or something like that saying that this is the new shit, this is the new coolest service in town, and you have a huge peak, and you can handle it for a while, because probably around here you start ordering new servers and trying to scale out your solution. Instead, if you have the actual load and you can have your IT infrastructure get closer to this load, you have a lot of benefits. Well, you have a lower capital expenditure because you don't have to make the initial investment in buying this hardware. You can rather move this capital expenditure to operational expenditure, that is running costs, instead of investing a lot in the beginning. No capital lying idle, no screaming customers. Your platform is able to adapt to these demands, and you can also turn down. So after this initial hype, you could turn down your demand, and you can then scale up again. So this is all possible with the cloud, but it's not really that easy to just say I'm running in the cloud and automatically I will adapt to everything that's happening. So the autoscale, some different ways of doing this is, one is to monitor performance counters. So you have, for instance, if you're running on 2 web servers and you see that these web servers are utilized 80% of the time, or the CPU is 80% or it's 80% usage, then you could say that, okay, if I'm this high for this amount of time, I need to add more servers. So this is one way of autoscaling. Another way is monitoring queue length. So if you have I'm using a new pen all the time. So for instance, if you have an application and you have a queue, and then you have something that's processing these messages, we're going to talk about asynchronous messaging later, you could say that if this queue is more than 100 messages, well, then I need to scale out in the backend. I need to add more servers taking care of these messages. If it goes down to below 10, then I can remove 1. If it goes down to 0, I can remove another 1 or something like that. So you could monitor the queue length and see that this is an indication that's saying that you need to scale out. And what you do is, well, you add more resources. You add more servers to handle the queue, or you add more web fronts if your web fronts can't handle the load and stuff like that, and simply add more resources. But this is also something that is very hard to get right if you're going to do it by yourself. So for us, it was very long that we had this on our list, something that we wanted to do. But instead of doing it from the scratch, we bought a company that already did it. So a couple of years, I think it was maybe a year ago, we announced that we bought a company that does the autoscale, that did the autoscale on the Windows Azure platform as a partner, but now it's integrated into several of our services. So Windows Azure supports autoscaling out of the box for Windows Azure websites, Windows Azure mobile services, and Windows Azure cloud services. So these are services, the compute services that support autoscale. If you go into storage, we have autoscale for queues and for service bus and for blob storage and for table storage, but not for the SQL stuff and not for virtual machines, but the other parts have. So autoscale. The way that autoscale is implemented in Windows Azure is that we monitor your services, and based on the output of this, we decide when it's time to scale out. So, for instance, the cloud services scale out is the most advanced. So here you have both the CPU and the queue. So if, for instance, if I use CPU, I could say that, let's see if we can zoom in here. I could choose the instance range. That is, I never want to have less than one instance, well, of course, but I will only scale up to 10 instances, or I will never have less than 4 instances, and I will never scale further than 10 instances. I could set the target CPU, so saying that if I'm below 60% or above 80%, I will do the scaling up or scaling out or scaling in. And we will check this every 5 minutes. So we take an average out of 5 minutes and then say, okay, you're above 80% of utilization of your complete server farm. And if we are, we will add, in this case, 1 instance. So this last slider is scale up by. So I could say that I want to go from 4 to 10, and if I scale, I want to scale with 2 instances at the same time. So going 4, 6, 8, 10. And this is also because scaling out with cloud services takes some time, because we need to start the new virtual machine. We need to take your deployment package and deploy that to these virtual machines and set up the load balancer and all that stuff. And it takes between, as I said before, 5 to 8 minutes to start a virtual machine and deploy an application. So you don't want to, if you have like minutes here and you have a peak, you have something going like this, you do not want to scale out. You want to see that this is continuously growing to be something like this before you do the actual scale out. Because if your peak is already gone when you here decide to add new resources, and if your resources is available over here, it didn't give you anything. So there are several other patterns connected to the autoscale. For instance, the throttling pattern, where you can say that, okay, in the case that I need to scale out, to be able to handle my requests, I will start throttling requests. So start blocking some requests, making them retry their request, for instance, and try to lower the load on the servers until you have been able to scale out, to then be able to let go of or start using all of the power again. The other option is to say the queue length. So in queue length we have the same with the instances running from and to, and you could then select a let's see, an account, and I think I should have a queue here. Yeah, saying messages. So here I could say that the target for the target per machine is, in this case, 2,000. So if there is more than 2,000 messages in the queue per machine, so for instance, if I have 10 10 worker roles working on this queue, I need to have more than 20,000 messages in the queue before the scale out happens.
Is that averaged by time as well, or is that the peak thing?
I think that is also checked like every 5 minutes. I think it's every 5 minutes. And if we look at, for instance, the Windows Azure websites.
One more thing there.
Yeah.
Is it CPU or queue, or can
Yeah.
it be combined?
No, CPU or queue. So if we look at the Windows Azure website and look on that scale, we see that it's a little bit simpler. So we only have the, I have to go to shared, I think, or standard. So we only have the CPU here, and I can say that well, basically the same thing. You also have the possibility to set up the schedule times. So I could say that on weekends I want to scale from 1 to 2, and on weekdays I want to scale from 4 to 8, for instance, depending on how your traffic pattern, what it looks like. Autoscale issues and considerations. As I said, it's not an instant solution, and you need to be aware of that, so that you will not be able to scale instantly as soon as your peak arrives. And we have parts of that implemented, since we only check every 5 minutes, and you can set for how long should it be before I scale up until I check the next time. It was a setting for 20 minutes by default. So, for instance, if you do scale up or scale out, I mean, we won't instantly scale you back if the load increases right away, because you don't want to end up in scaling up and scaling down. I say up all the time. Scaling up is adding more resources to one server. Scaling out is what I'm talking about. And it's not a guarantee of performance increase. I mean, you still have to build your solution to be able to really scale. For instance, avoid instance affinity. So don't build a solution that requires the user to come back to the same instance. So if you have a scale-out web or web fronts of five web fronts, then you need to build them stateless, so that your users can end up on a new server all the time. Because if you have a lot of if you have 2 web fronts, for instance, and you have a lot of users, so we say we have a lot here and a lot here, and then you add a new resource and you have not used instance affinity, that is, these users are all directed back to the same computer, well, then no one will use this, or new users will use this, but the existing user base on your service already will be routed to the same servers. What you also need to do is to handle long-running tasks. So, for instance, if you're doing something with a message from a message queue, and you are in the middle of processing this message, and the message processing takes maybe 2 minutes or 3 minutes or 10 minutes, and then there's a scale back or scale in event happening, then you need to handle that that message that's already in the processing. So that is something also that you need to be aware of. And then we often, when I talk about scalability, I talk about the scale units. So, for instance, if you're building your solution with a bunch of web roles, maybe these 2 and these plus storage queue in the middle or something like that, these could be different scale units. So, for instance, if I need to scale this one out, well, then I also need to scale this one out, because they are sort of connected together, although they might not be connected like this, but they could be connected in the usage scenario. That is, I scale these as a unit. So you need to be able to map your solution to these different scale units, so that you know which parts to scale when you need to scale one part. Okay, next pattern, compute resource consolidation. We talk a lot about, in the industry, we talk a lot about separation of concerns. You want to have one unit dealing with one concern. So keeping things as separate as possible, and have this discrete computational units doing each of the processing steps. For instance, it could be inside your application that you want to have one class doing only one thing, or one method only doing one thing, or it could also be in the way that you architect your solution, saying that this server or this backend worker should only process this queue, messages from this queue. These are then hosted or could be if we're talking architecture, they could be hosted and deployed individually. So this of course increases the cost and also adds more complexities to your solution. So say that you have 10 different queues with messages that you need to process of some kind. If you're going to have 10 worker roles, each just processing one of these queues, which would be the perfect separation of concerns, then you would have 10 different deployments and 10 different reasons to scale out or things to monitor and stuff like that. So the compute resource consolidation pattern is very good to use when it's not cost effective to run these separate. It is also good to use when you are sharing resources locally. So if you have these two worker roles and they are sharing some sort of local resource, they could run on the same machine, and those sharing the resource on that machine and also sharing the computational resources. So if we look at a demo, how this could be implemented, for those of you who have experiences in Windows Azure, you know that the implementation pattern of a worker role is an infinite while loop. So if you leave the while loop in a worker role, our data or our monitoring software will think that there's something wrong with this, and we'll shut down the server and restart and redeploy our package or whatever we do, but take this back online again because we think that was sort of an unhandled exception. So if you do file new project on a worker role, that is what you get. What I've done in this example is that I instead use tasks. So I built a number of tasks, a logging task and a messaging task. And if we look at the implementation of one of these, it's a asynchronous operation, so using the C# keyword async. And then I do some sort of processing inside of this task while I don't get the cancellation request. So as long as there's no one telling me to cancel, I do some processing and then I do a task delay on an interval. And the interval in this case is 10 seconds. So I do some work and then I sleep for 10 seconds or wait for 10 seconds. And then I do the same work again and I wait for 10 seconds. So this is sort of the pattern for how to use a background worker in Windows or in Windows Azure. Do work could be, for instance, checking a queue for a message, process that message and then delete the message. Go back and wait and then do the same thing over and over again. If we look at the logging tasks, it's the exact same thing, but in this case it's waiting for 5 seconds instead of 10 seconds. So they have sort of the same computational resources that they are using. There's not one of these that's using a lot of resources by doing short intervals, but they are sort of sharing the resources. Jobs run every 5 or 10 seconds in this case. And if I look at the worker role implementation, I start by creating a list of tasks. So I have just a reference to these different tasks. And then I add all the tasks to a task list. And then I say task.waitAny. So what waitAny does is that it says, okay, I wait until any one of these tasks is ready for or leaves their method. But since all of the tasks are in an infinite loop, none of them will leave until something actually breaks. So this is one way of implementing one worker role that deals with several different things. So what I could have done instead is have 2 separate worker roles, each or one with a logging task and one with a messaging task, and let them run on separate computational units. But instead, you could bring these 2 together and run them on the same virtual machine. What happens when you stop or when you send the cancellation token to this? The the requests will end, and you have, I think you have in the emulator, you have 30 seconds to finish the final request. Otherwise, Windows Azure will stop you immediately. And in the cloud or in the real Windows Azure world, you have, I think it's 5 minutes. So if you have long-running tasks, you need to understand that if you are for some reason canceling and you're in the middle of the process, you need to be able to shut down within 5 minutes. Otherwise, we will shut you down. I don't have my keyboard shortcuts in my. So if we run this, we could just start it up. So for those of you who haven't used Windows Azure, what I'm doing now is I'm starting the compute emulator. So this is a fully emulated environment of the Windows Azure platform, or parts of the Windows Azure platform. So if I open the compute emulator UI, I see that I have a deployment of resource consolidation. It has one role and one instance. And here I see the different tasks doing their work. So 2 logging tasks on 1 emailing task would be the 5 and 10 second delay for these tasks. So we can stop this or remove this one. Find the right slide. Compute. So be careful in using this when tasks have different scalability requirements. So for instance, don't add one that needs a lot of resources and maybe that you want to scale out to 10 instances together with something that basically only needs 1 instance. Because then if you scale one, you will scale both since they are running on the same virtual machine. Also, if you have conflicting processing requirements, one that needs a lot of CPU and one that needs very little, that is probably not 2 good candidates of baking into the same cloud service. Or if you are processing highly sensitive data, that is, you do not want to share the resources between these two, because once they are running in the same cloud service, in the same virtual machine, they will have access to the same resources and run in the same security context. So if you have things that needs to be separate, then don't put them together. Any questions so far?
I have one question.
Yeah.
A couple of years ago, when I used Azure, we had some problems accessing the log files. It wasn't very intuitive. We had to use some third-party Azure Explorer or something.
Yeah.
Is it easier now to actually access the log files?
So the question is, a couple of years ago, it was sort of hard to access the log files, and now is it easier now? You had to use some third-party tools to get that stuff out of the cloud. As you might have seen, if we look at one of the cloud services, you get some parts of the, for instance, performance counters was a hassle to get out before. Maybe I should stop the presentation. So, for instance, you see performance counters showing up directly in the portal, and I think you can also you can add new metrics. So you could say that for this I wanna see the network in or network out or stuff like that. So there are some performance counters already accessible directly from the portal, and sort of depending on which server it is. I think for websites, for instance, you can download. Maybe you have to configure it first. Platform certificates, domain names, SSL, application diagnostics. So you can you can set up a lot of this directly from the portal now. It's very different from before. I would say that some of the tools are still definitely viable. For instance, the one tool where you can basically, not in real time, but almost real time, where you could at least replay the way that your application behaved during certain times is still very, very good. We also have full integration with System Center. So if you're using System Center for monitoring on-premises application, you could use the same product for monitoring also the cloud. Next pattern is the direct client's resource access control. So for instance, if you have a user trying to access something from a target resource, an image or a file or something like that, one way you could build it is that you have your application code, and the user request comes from here, and the application code fetches the resource and delivers it to the user. So this would be the traditional web application with a web browser and the file store or something like that. And the same goes for the other way around. If the user want to upload a video, for instance, well, the user could upload the video to your web application, and the web application would take care of storing that in the data store. This approach uses valuable resources, of course, with compute, memory, and bandwidth. And what in reality most data stores can handle direct upload and download from the client. I would say that this sort of depends on which data source you are using. So for instance, on SQL Server, I would not use this pattern, but on blob storage, for instance, or queue storage even, I could definitely use it, because it requires the security credentials. So you need to be able to hand out the security credentials to the client so that they directly can upload the data. So this would look something like this. The user accesses a resource from your application. Could be a web browser and a web server. And the web server validates the request and generates a token for the resource that the user is requesting. And this token is returned to the user, and the user is using that token directly to access this resource. Demo. I sort of see that the pattern descriptions are getting shorter and shorter, but that is probably a good thing. Okay, so we have the direct client access resource. So, for instance, if we look for a picture of no, I can't spell Lady Gaga. And pictures. Take one of these and save picture. Lady Gaga on pictures, and then I upload this to my storage account. So I have a storage account saying named Eriksen private, and that contains one container, says private container. So you understand that this is a private container. So I upload a blob to this. It was under pictures and Lady Gaga. I upload, and you also see that fully integrated into Visual Studio we have access to blob storage, which, if some of you haven't looked at Windows Azure for some time, this is new. So now I uploaded the image to the blob storage account, and if I right click and say copy URL, and I try to access this, I get a 404 saying that the resource was not found. This is because it's a private resource in a private container saying that you're not allowed to access this resource. So we don't even say access denied or something like that. It's a 404. We didn't find it. So what I can do now is that I could write a small program. This is just a console application saying that on this storage account I want to access the private container, and in that private container I want to get a reference to the blob named ladygaga.jpg. Then I add a policy, a shared access blob policy, saying that for the next 10 minutes, I want to allow reads and writes to this URL. So if I have the URL and I have the shared access key, I am allowed to do reads and writes. I set the permissions on the blob, and I generate the shared access signature token, and then I just generate the full URI from the blob URI and the token. I set this to clipboard just for convenience, and then I print the full URI. So if I run this application, I will get a URI created for me. So we see that it's Eriksen private.blob.core.windows.net/private container/ladygaga.jpg, and then a shared access signature appended to that URI. So now if I access the same resource, it is still not available, but if I add the shared access signature, I will be able to access the resource. So what you could do, if we go back to the slide describing this, is basically what I did is that I implemented this exact pattern, that my code accessed a token, and then I used that token and I opened a web browser and I did a regular HTTP get on that resource, and now it was returned. This could be done for queues also. So for instance, if you have a mobile application and they're gonna upload a movie to blob storage and then post a message on a queue, you could say that you're allowed to do this for 10 minutes, but after 10 minutes the permission will be revoked again, and you will not be able to use that signature any longer. And of course, the validity period is to be chosen carefully. So for how long do I want to allow my users to be able to use this URI? There is no count implemented. So for instance, one implementation could be that if this is used once, then it's revoked automatically. We today only have the time limit that could be set. So you need to choose this carefully, because you don't want to have it too short, because then your users won't be able to use it, and you don't want to have it too long, because then they will be able to use it for something else. So now, for instance, since I gave read write and access write, read write and write write to that resource, someone could be able to do a HTTP put to that resource and overwrite my. So keep the level of access tight. Only give them what they actually need to do. For instance, if they are uploading stuff, you could give them only write writes and not the read writes. And you also need to think about, how do I deliver the key to the client? If I generate the key on the server, well, how do I give this key to the client? Normally this is done via SSL and encrypted transfer, of course, but you need to be aware of how this key is supposed to be delivered to the client. And also, as of always, protect the data in transit. So we don't encrypt anything inside of Windows Azure, but we support encryption for all the data that is in movement. So we have HTTPS possibility on all of our services, of course. But this is some of the things that you need to think about when starting using this pattern. So asynchronous messaging. I'm over time, but no one has arrived yet, so I'll continue. We have seen some parts of asynchronicity in the previous code examples, but async is really the key to scalability. So either in your code, being able to call stuff asynchronously, or in your whole architecture, being able to use a queue, for instance, between your different roles, so that you can have that sort of as a buffer between the web front, for instance, and the worker role, being able to stack up work. So with using different queues or a queue between your services, you don't have to have both services online at the same time. You could, for instance, have the web front available, and that could post messages on the queue, just saying that, okay, thank you, we have received your request, we will take care of it eventually. And you could scale these two parts separately. And the basic operations on a queue is the post, retrieve, and peek. So post, posting a new message on a queue, retrieve, retrieving one or several messages, and peek being a non-destructive operation where you only basically look at the next message or the next number of messages. So the simplest solution for sending and receiving is that you have one sender on one end and you have one receiver on the other end. And you have this queue as the buffer in between. So someone is putting messages on a queue and someone else is receiving a message from this queue. But you could also, of course, have several senders and several competing consumers competing to get the next message, so to say. And in this picture, there are 3 on each side, but it could, of course, be 10 web fronts and 2 worker roles, saying that, depending on how you wanna scale your solution. Another option is to have one shared queue where all of the sending messages goes into the pipeline. We have 3 receivers picking each message that comes from the queue. And when the message is processed, they post the message back to the dedicated queue for that specific sender. So for instance, this sender sends a message saying that I am sender A and this is my return queue. And when the queue, when the message goes through the queue and ends up on one of these receivers, they look, okay, where do I send the response? They do the processing and then they send a response to the right or corresponding queue. Another option with queuing is to build a publish and subscribe. So for instance, if I have a topic, I can have several different receivers. So in this case, if one message goes to one receiver, these 2 receivers will never know about that message. So it's only the one that's picking the message that will actually get the message. But if you have topics and subscriptions, you could say that this receiver should receive all the messages just for monitoring or logging, while this one should receive all the messages with high priority, and I have another receiver just receiving messages for the low priority, for instance. So from the sender perspective, it's only one queue as an in parameter, but this could be spread out to several different queues. And what you could also do is that you could, in the later stage, add another subscription to the same topic and say that, okay, now I want to subscribe to these kind of messages or stuff like that. So if we're looking at queuing in Windows Azure, we have a bunch of different queuing solutions. So we have the Windows Azure storage queues that has been there since the birth of Windows Azure, and we have the Windows Azure Service Bus queues, and we have the Windows Azure topics and subscriptions. But these are actually designed to handle different situations. So if we compare the 2 that are most similar, the Service Bus queues and the Azure storage queues, if you go through these steps, you will pretty soon find out which solution is best suited to your needs. So for instance, the Service Bus queues are, you select a size when you create the queue, so the queue should be between 1 and 5 gigabytes maximum. While in the Azure storage, there is no actual limitation, but the limitation is on a storage account that cannot grow bigger than 100 terabytes. Scalability targets for messages per second is the same, but the average latency is higher on the Service Bus queues. The max message size is 256 kilobytes for Service Bus and 64 kilobytes for Azure storage queues. And on Service Bus queues, you have a number of features that's not available at all in the Azure storage queues. So for instance, you could say that you want order delivery. So if order delivery is important to you in your queuing solution, well, then service bus queues is basically the only solutions that you have. You also have full WCF integration, so you could, for instance, build an on-premises solution that talks WCF and have that post messages on your service bus queues. You could also receive messages without polling, so you don't have to go ask the queue all the time if there are any new messages. Rather, you open a connection to the queue via TCP, and when a new message arrives, it gets delivered to your service. On the other hand, on storage queues, you have something that we call progress tracking in messages. So we talked about earlier about handling long-running tasks. If you want to do that with and you're using storage queues, you could update the message with how much you have processed. So say that you have 5 steps that you need to take care of, then you can go back into the message and say that, okay, I'm at step 3, or I've done 75% or something like that. So when the next, if you have to stop your processing and someone else will take over, then they can start where you left off instead of starting from the beginning. Storage queues mainly to communicate between roles in the same Windows Azure cloud service. So if we are building this, composing an application of cloud services where you have maybe a web role and a worker role and stuff like that, and you need to have communication between these, then the Windows Azure Storage Queues is what it's built for. If we're instead talking about large-scale integration solutions where you have several different clients and you have maybe on-premises and you want to expose the WCF service on the service bus and stuff like that, then probably the Windows Azure Service Bus Queues is a better options. And the Windows Azure Service Bus topics and subscriptions is when you want to broadcast messages to multiple receivers. So for instance, if you're building a publish and subscribe solution where you publish one message and you want to have several subscribers listening to these messages. Some things to think about is plan for idempotency. That is, most of the queuing solution is guaranteed delivery of at least once. So your message will, for instance, if you have 2 worker roles that are competing for messages and one of them picks up a message and for some reason breaks while processing it, the message will pop up again on the queue and someone else will start processing this. So say for instance that you are doing online e-commerce site and you place an order. So you have a message that is the basket of stuff that you have bought. And you start processing this, and for some reason your one server that took this message breaks down and the message pops up on the queue again. And you were basically finished with processing it, but you hadn't had time or didn't report back to delete the message. And then someone else would pick up the message and start from the beginning. That is typically not an idempotent process. So you need to be able to run the process several times to be fully idempotent. You could have something like message grouping. So say that if I have a queue of messages and it's really important that message 37 is handled before 38, it's not optimal that you have a relationship between these messages, but it could happen that you have that kind of solution. Then it's good to have some sort of a possibility to group messages together. And Windows Azure Service Bus have support for grouping. Repeated messages, if the exact same message comes to the queue again, what do you do in that case? And there are several different solutions for repeated messages. For instance, Windows Azure Service Bus can detect this automatically and just discard repeated messages if you don't want to process them again. There's also something called poison messages. Poison messages is messages that basically breaks the one handling the role. So there is something wrong with the message, which means that every time someone else tries to process this message, for instance, it's trying to access a resource that doesn't exist, and then everything breaks down. this will be a poison message that will appear on the queue over and over again. And then you need some sort of mechanism to check if this message has appeared several or a number of times, then I need to remove it and put it on another queue. Message scheduling. I could also post a message on the queue and set that this should not appear on the queue until 5 minutes or 2 days later or something like that. And Windows Azure Service Bus also have support for message scheduling. So this is something that you need to sort of consider when you start looking into asynchronous messaging solutions. Questions on that? Going into the final pattern, being sharding. So as I said before, scaling out the stateless web front is easy, but scaling out the data store is hard. For instance, if you have I drew this picture earlier, but if you have your web front and you have your database, you could scale this out really easy. It's just adding more resources, adding more virtual machines to your load balanced web front. But what to do with a database? Well, one thing would be to grow it, to add more, to scale up, to add more CPU or more memory to this database. Another thing you could do is, of course, to implement the cache. So stop as many requests as possible from reaching your database. Even another thing you could do is stop as many requests as possible to even reach your web fronts by using content delivery network. So these are ways to handle this, but it would be an optimal solution if we could also scale out the data store. So when we talk about sharding, we divide the data store into horizontal partitions or shards. So all the shards share the same schema. So we don't, in horizontal partitioning, we don't change the schema between the different databases, but they rather have the same schema. And you shard by a key or a partition key. You have a shard key or a partition key. So for instance, I could use range-based partitioning. So I have one data store here saying that here I have a shard key of being customer ID. And saying that in this data store I have customers ranging from 1 to 1,000. In another data store I have 1,001 to 5,000 and so forth. Yeah. A problem with this approach would of course be that all of my new customers always end up in the newest database. And if I have a pattern saying that new customers tend to buy more than old customers, well, then this database will be overutilized, and I will have a problem. So this is probably not a good solution, not a good selection of sharding key or partition key, but it would be an option to just use the customer ID and shard from that. Anyway, the way that you choose your choice of partition key should be based on attributes of the data stored in that data store. So for instance, if you have a customer entity, you should use some of the properties, maybe one of the properties or a combination of the properties, to find the partition key that you want to use. So that based on the entity that you have, you should already know where to place this. This could be, of course, a customer ID, or it could be a unique identifier. That is a GUID, or it could be the state or the city they are living in or something like that. We could also generate a sort of uneven population, with the Stockholm database being the biggest one, and so forth.
I assume that it is a good idea to use pretty static data to do this, so that they... Yeah.
Exactly. So it needs to be static. So for instance, in Sweden we have personal identifiable number for a customer. That is something that is static in most cases, or in most cases it probably could change. but it would be a static ID connected to that person. Also, unique identifier seems to be a very good key to give an even distribution between this. It could also be a hash, for instance, with a hash of a username, or I don't know, something like that to give you the partition key. So what I've done here is that I've created two databases. So I have the same schema. I have a database project with a customer entity containing just like first name, company name, and I'm using here unique identifier as the key. I have deployed this to two databases, so Sharding Customer DB1 and Sharding Customer DB2. So two exact copies of the database. And then I built a post-deployment script. So when I do a deploy, I check if I'm in DB1, and if I'm in DB1, I do some inserts of users or customers. And if I'm in DB2, I do some other inserts. So I have two different databases. Today just, or in this case, just randomly inserted into these different databases just to have something to start with. So let's close this and see if we have the program. So first of all, let's test the distribution of a GUID. So what I do is I create a customer, or I create 100 customers. I set the ID to a new GUID or unique identifier, and then I find the bucket for the GUID. So in this case, I have two buckets. That is, I have customer DB1 and customer DB2 as my shard list. And the find bucket for GUID just converts this GUID to a byte array, and then converts the byte array to an integer, and then does a modular division on the number of instances. So I get a 0 or a 1 out of this GUID. So if I run this application, generating 100 customers, I get 48 in one in number 0 and 52 in the second one. So pretty good, evenly distributed on just using a GUID. If we add a couple of more here and say that we want to run 100,000 maybe, I get closer and closer, or maybe not closer and closer, but still it's a fairly good distribution between the different buckets that I have. So when I want to create the customer, I need to so I create a new customer. I name it Lisa with 2L in the beginning. I create a new GUID. I find the bucket for the GUID, and I use this as shard ID from my it's probably really small. The bucket that I get, I use that when I create my customer DB context. I use that connection string for that bucket, so that based on the customer that I've just created, I know which bucket this should end up in. So if I run this part instead, adding customer to shard 0. So if I run it again with a new GUID, I should eventually end up. I should end up in another shard. So the important thing here is that you need to have some way of knowing how to find out where your customer should end up, or if you are querying the data, where your customer is. So based on maybe login name or login username or something like that, you need to be able to transform this to where you should find your information, or the information for this user. What you also might need to do is that you might need to do a so-called fan-out query. So say that we have these different data stores, and I have 500 users here and 300 here and 2,000 here. And I want to find every user that lives in Stockholm. Well, it could be 30 here, it could be 25 here and 1,000 here. Then I need to, some way I need to be able to make a query and execute this query on all of these data stores and then aggregate this solution to 1055 and return that back to the user. So when you are building sharding solution, you need to do stuff that minimize the number of fan-out queries that you do. So optimize for online reading and do fan-out queries maybe for reporting and stuff like that. So if we look how the fan-out query could be implemented, I'm creating a concurrent bag, so just a thread-safe place where I could store the stuff that or when the queries are finished, they could use the same place to store the end result data. And then I do a parallel for each on the shard list, so the shard list that we had before. So I do a parallel for each, so running these in parallel. And then I say find all the customers where first name contains double-L. Executing the command against the different shards and reporting how many I found on that shard. And then I add the results to the results concurrent bag. And then when it's all finished, I print out the results that I get back. So if we run this on these two databases, we don't need to create any more customers. We do the fan-out query. We see that we are executing the queries against shard 0 and 1, and we get 10 from one and 2 from the other one, and then prints out all the different from both data stores. So fan-out queries are of course expensive, since you need to go through all the, especially say if you have 100 data stores. So used carefully when you really need to do the fan-out queries. So as I said, choose your partition key with care. Be careful in using @identity or date. So don't use things that just adds, because if you use date, for instance, then all of the latest things that you add into this will be in the same data store. And if you have more traffic on your latest customers or stuff like that, then they will all end up in the same data store. Avoid fan-out queries online. So optimize for reading for your end users and maybe not for reporting. And replicate reference data to all shards. So say that you have a zip code table or something like that, then you could, which is sort of static data, then you could replicate this to all of the different shards, so that if you need to do a join, for instance, on zip codes, you have that kind of reference data locally on each of the shards. Okay, as I said in the beginning, this is based on guidance from the Patterns and Practices team. So I'm going to put that back up again if you want to see it. But if we look at not the Lady Gaga picture. So they have the Patterns and Practices Windows Azure guidance site with different different themes, moving to the cloud, deploying for the cloud, and so forth. And the latest edition is the design, the cloud design patterns. And when you download the cloud design patterns, what you get is these Word documents. So 35 items, I think it's 5 guidances and 30 patterns or something like that. So all of the ones that we've been talking about, for instance, the multi-DC deployment, have a full description of why to deploy to the multiple data centers and stuff like that, and also implementation on, I think it's, no, probably not the traffic manager, but references to where you can read more on the related patterns and stuff like that. So it's a really good resource if you want to understand more about cloud computing and also how you can use this in your own applications. It's not happy with me. And as I said, my role is technical evangelist for Windows Azure. So basically, this is what I do all the time when I'm not talking to customers. I'm out evangelizing our platform. So please contact me if you have any questions or if you want to discuss an architecture for a solution or something like that. It's an auto change on this one. Well, okay, so that was it. I'm gonna continue doing this so you can take a picture. Do we have any more questions?
Can you say something about AMQP?
No.
Okay.
So the question was, can I say anything about AMQP? No, I have no knowledge at all, actually. Yes?
Can we get some of the source code examples with the slides, maybe?
Definitely. What I was thinking about doing is posting it on my blog. So I can add if I distribute the slides through you, I can just basically give you links to the blog post. So that will probably take some time before I get that up and running, but I will definitely do it.
How are you for persistent storage when it comes to openness? You mentioned different operating systems, Linux for example,
Yep.
Programming languages, PHP, Java, other competing languages with .NET platforms and
Yep.
so forth. And but how about different persistent storage
Yep.
solutions like Riak or Raven,
Mongo or
Oracle
something like
or
that.
whatever?
Yeah. So the question is, how about data stores from other providers? So if we look at the Windows Azure portal and we say we create a new virtual machine and say from gallery, here you have a number of different servers that you can start using. So of course the Windows ones, we have ones with SQL Server already installed on it. But also if we look at Oracle, we have images with Java, the JDK, and also WebLogic and Oracle database. Under Ubuntu, we have the Ubuntu servers, but these are plain vanilla Linux servers with the distributions from our partners. So it's not a Microsoft distribution of Oracle or of Linux, but rather partners working together with us. And on these, you could basically install anything. So if you want to run a React database, I would say, well, spin out the Linux distribution that you want to use and install the database on it. What we also have is that we have something that's called the Windows Azure Store. So in the Windows Azure Store, I can purchase services that partners to us deliver. So for instance, on we have CloudDB MySQL. So if you want to use MySQL, we have it's called the MongoDB and the Mongo Lab. So two different providers of Mongo databases. This one being from MongoDB Incorporated. And another thing that we have is the VM Depot. Nej, VM Depot. So everything that is open source within Microsoft runs through a subsidiary called Microsoft Open Technologies. And what they've done is that they have built a repository of community-created images. So for instance, if we search for Riak, there might be a distribution, yeah. So here you have a React database running on CentOS, and also with a deployment script directly available. So you just select the region. I want to, oh, this is not working. Okay. I don't know why this isn't working, but what you could do is that you could select a region and saying, okay, North Europe, and then you would get the deployment script to just execute this in PowerShell or in we also have command line tools that you could use on Linux or Mac, and it will deploy it automatically directly to your storage account.
How do you publish stuff to the Azure?
Excuse me?
How do you publish things to the Azure store?
So how do you publish things to the Azure store? First of all, you have to be a US-based company as of today. So it's sort of hard at the moment. So the Windows Azure store is still in preview. So if we look here, store is still in preview. And I don't know the exact roadmap for that, but of course it will open up and there will be an SDK available. So for instance, if I choose to create a SendGrid, for instance, there will be an SDK available for adding this description and adding the logo, and you can also add the different plans that you have. So there is an SDK available, but today it's a limited use of it, and you also have to be a US-based company. But we will open up more of that in the future. Yes. Okay, so the question is, I see this preview mark every here and there. Are these services not available to all users since the Windows Azure Store isn't? No, I would say it sort of depends on which server it is. So the Windows Azure Store is available for all users to use, but it's only available to US publishers to publish new stuff. For instance, the scale part is in preview. So the service, if we click on mobile services, for instance, mobile services is released, but the scale inside of mobile services is in preview. So what preview means is that we don't have an SLA for it. We might change things without telling you beforehand. And it's also, it basically means it's under development and with different stages of completeness, I would say. So far, I think that there is only one service that we have revoked from Windows Azure, and that is the Windows Azure VM role, which was a non-persistent virtual machine role, where you could basically create your virtual machine and upload it to Windows Azure, but the disks were not persisted. So that is basically what we replaced with the whole infrastructure as a service offering. So we replaced it with something better. I have not seen anything from preview been taken out of preview and just removed. So well, it's no guarantee, but I'd say at the time that they reach public preview, they have already gone through a private preview and an internal preview and stuff like that. So yeah, exactly. Yeah. They are also, if we search for, I never seem to be able to find this page, but if I search for Windows Azure preview features, there is also a page where you can sign up for things that are not just showing up in the portal as a preview, but rather something that you need to access. Billing alert service, for instance. I didn't know about that one. Windows Azure import and export service. I think this is where you can use like FedEx to send the hard drive to the data center, and we will plug it in and upload it to your storage account. So it's probably, if you want to upload terabytes of data, it's faster to use FedEx than to connect it to your internet connection and publish it that way. Available in the preview only in the United States, so currently not available in other countries. So here you have, for instance, Visual Studio Online, enabled for all accounts. Still in preview, but enabled for all accounts. Okay, I'm not flying home until tomorrow, so I have all the time. And it seems like the Coding Dojo kids went home. Yep. Thank you.